So, welcome back, Delilah. Okay, so we've got Delilah back. Now, so there's our light source. I'm going to indicate a light source just by putting a little LS there. And we're going to imagine, a ground plane like this. So, if you drop the light source directly down to the ground plane, or in this case, a more precise way to say it would be the plane on which the shadow is being cast, because sometimes you can do this to a wall or to a tabletop or something. Well, for now, let's just say the ground plane. When you drop it down here, you're going to get what I'm going to call the radiation point. All right? Now, this is called the radiation point, not because we're trying to make perspective sound as cool as nuclear physics. Okay, it's called the radiation point because it is the point from which all the shadows radiate. Okay? They come out from. So, this is how simple this is. Everyone just eyes up for a sec. Drop the note taking. The radiation point through the base of the object gives you the direction of the shadow. The light source gives you the length. That's the shadow. That's it. That's as hard as it gets. Yes, it's that easy. All right. Now, what does this look like in 3D? In 3D, it looks something... Oh, I just realized what's going on. I was thinking, why is that so dark? Okay. I was doing some soft pencil drawings, and it was kind of messing us up because it didn't look quite right. Okay, so anyway, so what does this look like in 3D? What it looks like in 3D is something like this. So here's Delilah. Here's our light source. And I'm going to arbitrarily pick this spot as the radiation point. Okay, so again, eyes up. Watch. That gives you the direction. That gives you the length. That's the shadow. That's it. Yeah. Well, here's the thing. I don't know. When you have something floating, like a light source, I actually don't know where it is until I indicate where it is relative to the ground. So when I pick this arbitrarily, what I'm saying is, the light's in front of the object. It's closer to us than the object is. If I would have said this spot, you guys take a look. If I would have picked that spot, do you see that the shadow would have been going this way and actually that the light source is quite a distance away from us? If I would have put it here, do you see that now the light source is like way out there, but it's not that tall? You see what I mean? So it was totally an arbitrary choice. Now here's the thing. If you were doing a drawing of a room like this, and let's say I had a spotlight right here, okay, now it's not arbitrary. Now you have to find the spot on the ground directly underneath it, and we'll talk about how to do that next week. But for your cube drawing, you can just say, okay, it's here. And you can go with that and you'll be fine. All right? But does this make sense to you guys? Mm-hmm. Pretty clear? Yeah.
So for making the angle of the light source, when you cut off the part of how long it would be, is there determined by a certain angle, like a certain...
Now,
you decide how long to make it for the an angle from the light source and the radiation point?
No, all you're doing is this. It's if you go through, if you take the radiation point through the base of the object, that will be a line along the ground plane showing the path of the shadow. And then the light source coming down through the top of the object will cut it off. And so you're just kind of going and saying, okay, it stops here. Yeah.
So what would happen if that shadow hits another object?
I'm glad you asked that question. All right, so let's time for a second. What if there were, for instance, a corner, like say a wall behind this object, and it was right here? What would happen? Watch. It's so stupid. It's so easy. You know, does that make sense? You know? Yeah.
So if you take the measurement, if it were to go through the wall, and you just put it up, going up.
Here, that's a great question, and you don't even know how good of a question that is, because one of the things is, when you guys go to do shadows as you go further into more complicated objects, you're going to have some problems, and they're easily avoidable problems. So here's my advice to you if you're ever working with shadows and you're confused. Okay? Act as if the object you're trying to find the shadow for is the only thing in the space. Ignore the walls, ignore any other objects, ignore everything. Because if you can understand, hey, I'm putting